Good morning everybody. This is the second video to show you the planning for a function, and this time around I'm going to do the planning right from scratch. So we've got a question and I'm going to use program 13 from Vtela Sphere Volume Application. So if I read the program, remember step 1, read it, know exactly what must be done in the program. An application must calculate the volume of a sphere. The user must enter the diameter and then click on the calculate volume button. The button must display the result of the calculation in the label result label. And I've got to use a function, calc volume, to calculate and return the volume of a sphere. The function must get the radius and send the volume back. Okay, so I need to start with the function. Need to read the question maybe more than once if you really need to have a look. The data, the formula is given to us. I can obviously go do a little bit of an internet search if I need to find more regarding this formula, but it's 4 divided by 3 times pi times radius to the power of 3. Okay, so I am going to start and say this is for a sphere volume application, the planning. The name of the function was given to us, didn't pay attention, calc volume. So name over here, calc volume. A name of a function consists normally of some kind of verb, in this case calc short for calculate, and then what would be calculated? Volume. So this function must get what? The radius. If I go have a look at the question again, the function must get the radius and send the volume back. So my parameter would be radius, data returned would be the volume. And now I can come up with a little bit of data. So that means if my radius is 15.5, it doesn't matter if it's millimeters, centimeters, but 15.5. If I've got 22.78 and I've got 4.61. This time around I'm definitely going to just do an internet search, calculate the volume of a sphere. We've got it here at the bottom. So they tell me I can enter the data. There we go. That page. If I enter a radius 15.5, it gives me a volume of 15598.53. If I enter a radius of 78, 2278, I've got 49516.48. If I enter a radius of 4.61, then my volume is 410.38. The steps would be declare the variables. Next, it would simply be calculate the volume. and my formula would be volume that's given to me, 4 divided by 3 times math.pi. There's a constant in the math class called pi, times the radius. Now the times math.power radius to the power of 3. There we go. Because the formula is 4 divided by 3 times pi times radius to the power of 3. Last step would be to return the volume. So this whole function would actually only have that one long formula for us. Okay, function is complete. I don't need other variables. I can simply calculate the volume from the radius. If we now go to the program, I've got a button, let's call it calculate volume, event procedure. So I'm going to call the button calc volume. For the button name, we always prefix it with btn because it's a button. All the user interface controls in programming, when I've got graphical user interfaces, prefix with a name that specifies the type. So btn for buttons. Okay, if I go back to the program, then it's maybe open it like this so that I can see both the question as well as my document that I fill in. So an application must calculate the difference of two numbers is wrong. Okay. The user must enter the diameter. So that means input would be diameter. Description, the diameter of the sphere. User interface control will definitely thus be txt diameter. That one is easy. The program must display the result in the LBL result label. And what would be the result? Calculate the volume. So, LBL result, if it's given, I need to use it. So that means the variable will be result, because these two names always correspond. And what would be saved in the variable? The volume of the sphere. Okay. And I can now again go and use test data. I used some radiuses as well already, but let's just stick to the steps first maybe, and then we'll add the other variables as they come along. So declare the variables would be step 1. Then I need to get the, or accept the, doesn't really matter which word you use, accept the diameter. When I want to call the function to calculate my volume, the function must get the radius. So now the next logical step would be to calculate the radius. And what would be my formula? I will need to save that radius somewhere. So I've got another variable called radius. It is stored going to store the radius of the sphere. Formula would be radius is equal to, obviously, the diameter divided by 2, because the radius is half of the diameter always, and I've got the diameter, so I can easily calculate this. Then I would need to call the function to calculate the volume. I'll just write that step over here. So I need to save that in result. The function would be called calc volume, and the function must get what? It must get the radius. And now I will need to display the volume to the user. If you want to, you can specify that it's saved in result. Okay, now I need to go have a look at some test data. If I only use Word, and most of you are comfortable with Word only, then I'm going to take those values and calculate the diameter. So 15.5 times by 2 gives me 31 on the dot for the diameter. I know 15.5, and I've already calculated the volume. I actually don't need to go and do it again. I'm quite sure the formula on the internet did its job. 22.78 gives me that. So I'm going to fill it in like this. Apologies. Oops. 45.56. So Excel would just make this process a little bit easier for me. And I've got 4.61. .22, and I already know what this volume must be. And if we want to, can add yet another column for one of my own other values. But using these that I've already devised, it wasn't given to us in the question, so I had to take my own radiuses. I can follow my data quite well. And thus the program is completed. I've got all the necessary documentation. Next step would be to translate this into a real live VB program. Thank you.